record. Welcome to Math 25, week 6, Tuesday. We're doing 10 exercises for mortgages, starting at number 7, where they admittedly get much more confusing. So for number 7, we have a family that we've used in the example problem from the very first day we talked about mortgages. So you can go back to that lecture note if you want. But all the information is summarized here, so you don't have to go back and look things up. We'll also need the amortization table, of course, when we're working on a mortgage problem. So all that stuck here on the slide. The question is, if compared to the Wall family, the Moneybag family doubles their monthly payment size, then does that make everything else double also? Or maybe something else will have, or something like that. So let's check and see if that works. So the Wall family budgeted 1,100 per month. Now we're going to double that to 2,200. So part A of this was how big a house size can they have? That was a division problem using the amortization table. So we will take the 2,200, divide it by a value from the table, and get how many $1,000 of house size they have. In our case, what table values do we want? We have to use everything else the same. The only number we're changing is the 1,100 per month. So 6%, 30 years, we're getting $6 is the table value. $22,000 divided by 6. So 366 about. I'm rounding down because we don't want to over budget. So that's how many thousands of home size. And we don't normally write a label with thousands. So we're just going to say that's 366 thousands of home size. So for B, then we're going to wonder what's the 20% down payment? So we'll take the 366,000 that we just did, multiply it by 20%, and the calculator will make that look like 0.2, left out of percent. So we got 70,200. So how much will their actual mortgage be? We'll take the 366,000, take away the down payment, and that's how much they'll need for their loan. $292,800. So let's compare numbers. We're not done yet, but we're out of room on the slide, so that's a good time to pause. So we doubled how much they wanted to spend per month on their house. We didn't change the other parameters of the interest rate or the number of years. Did the size of the home that they wanted double? Is 183 times 2, 366. So the old home price was 183. Now we're at 366. So yeah, 18 and 18 is 36. So that's twice the amount there.
Yes.
And the mortgage size, 146,400 was the old one. Now we're at 292,800.
That does seem like it doubled in size.
Yeah, so far everything's double.
Yeah.
Let's keep going. We still can check the monthly payment, and we can still see over all 30 years how much they paid and how much was interest. See if those numbers also double or not. So I'm going to take that and move it to the next slide. And take that and move it to the next slide. Oops, I am pasting instead of copying.
Also, I apologize for any background noise you might hear. My older brother came over to visit from the coast,
No problem.
and they're deciding to talk right outside door.
You might hear my son downstairs in his Zoom class too. Okay, so we have the 292, 800 loan size. So that means they have $292.8 thousands of loan. So we'll take the 292.8 and we'll multiply it by the $6 from the table. And 1,756.8. So that's their monthly payment. The old one was 878.40. That sure looks like twice it, so that also doubled.
Yes.
Finally, over 30 years, this should make sense. If we're paying twice as much each time we write a check, then of course, if we write the same number of checks, 12 a year for 30 years, we're going to wind up with twice as much money.
Yes.
So that shouldn't be surprising.
That would be the most logical thing, is if you're paying twice as much for the same amount of time, it would still be twice as much.
I'm writing it out mostly so that it's a review of how to do it the first time also. And of all of that, anything that's not the loan is interest. So we take away how much was the loan. we get 339,648. And this is perhaps obvious or not, depending on math background. If I take two numbers that are each double something else and subtract them, then the answer is also double the old value.
That does make sense.
I'm sorry, this one I circled. I should have circled those two as linked.
Yeah.
But yeah, if you take two numbers, double each of them and subtract them, then you're also doubling the difference between them. So yes, for number 7, if we start with changing only one thing and double that, all the other important numbers will double. They don't all work out like that.
Okay, that makes sense.
Problems.
So like numbers, and it's always good to go through and see if all of the numbers doubled or not.
Right. Although for 8, 9, and 10, as soon as you get to one that doesn't work, then you can just stop, because once it's broken, it's going to stay broken. Once you have numbers that aren't half or double,
Okay, that makes sense.
then it's not going to somehow fix itself halfway through. The pattern has stopped.
Yeah.
Should I do number 8?
Number 8 is a bit confusing.
Okay, let's do number 8. So we're starting over. We're ignoring the doubling that we just spent problem 7 dealing with. Now we are, whoops, I don't want that table with the green highlights. I want that one. That's why. Okay, so now we're going to take the length of time, the 30-year loan, and change it to be a 15-year loan. We're keeping all the other numbers the same. We're not changing the 1,100. We're not changing the 6%. So does taking the 30 and making it half as big make any other numbers half as big? Does that nice pattern keep going? So 15 and 6% gives us $8.44.
2%.
So part A, what home size are they looking for? They want to budget 1,100. Every time they pay $8.44, they can have $1,000 of home size. So we get roughly about 130,000. Again, we don't like labeling things with the word 1,000. We are math people. We would much rather write it as 130,000 of home size. And we can see right away that we're not doubling, right? Or not having.
Mm-hmm.
The old family
because
that
that number seems larger than the number that we started.
Right. So the table value didn't change with a half or a double. It went from $6 even to $8.44. So that meant that when we choose the different table value, then the home price didn't go in half to half. We don't have roughly 90,000. Instead, we have a lot more than half. So this is an interesting thing. It's saying that if you want to squeeze all of your payments into half as much time, going from 30 to 15, then you get more than half the house because you're paying off the interest sooner than it's sort of an extra good deal. It's an expensive deal because your payments each month go up. You have to have a better cash flow, but you don't have to settle for having half the house size just because you're having half the time frame. Number 9 asks a different thing. What if we have the interest rate? Instead of a 6% interest rate, we'll do a 3% interest rate. We don't have 3% on the chart, so I sort of broke the chart apart. So 3% and 30 years is $4.22. I had to give you that in the problem number because our table didn't have that. So we're having 3% in 30 years. Is this going to be half or double? So A, we're again looking at the home size. We're still using the 1,100. They have the same budget for what they want to spend. We're now dividing by a different number. And we get about whatever that is. 260. Again, I'm rounding down so we don't over budget for any family. So that's 1,000 of loan. We don't like writing the word 1,000 as a label, so let's rewrite it 260,000. Oops, I put loan. I meant home size. We have to take out the down payment before we get the loan. This is once again not doubling or half. We had the home size. We got a great deal. We waited until a time in our life when interest rates were really low. But unsurprisingly, if we go from $6 even to $4.22 on the table, that's not half. Half of 6 would be 3. And since we didn't get half here, then this number doesn't turn into anything that's half or double. So yes, we can get a bigger home for the same budget if the interest rates are cheaper. But it's not going to be as clean with math as just double. You don't get double the home size. Finally, problem 10, now we're taking the interest rate, and instead of a 6% interest rate, we're doubling it to a 12% interest rate. Somebody waited to exactly the wrong time in history and is trying to shop for a house when interest rates are gigantically high. So this is again not on the table, but for the 30 years and 12%, it just tells us in the problem that $10.29 is the number I want. So we were at 6%, which was $6 even. Did we double and get to $12 even? No, we're at 10 and change. So this is also not going to work. Let's look and see just how the math does happen. We're still budgeting for 1,100. But now we're dividing by $10.29. So we're getting about 106. So, and again, we don't like writing thousands as a label. We'd rather make it look like a number. Still not half or double.
No, it's not.
So we waited to the wrong point in history. Interest rates are really high. The old house was 183,000. Now we're at 106. So it's not as drastic as it could have been. It's not like doubling the interest rates means I have to cram my family into a house that's half the size. But it's a pretty dramatic cut from 183 down to 106.
Yeah.
So the point of these problems was if you're trying to budget for a house, how important are these factors? Problem 7 said that your budget is just a personal decision. If you want to pay twice as much a month, you will get twice as much a house. Over all the years, you will pay twice as much total. Over all the years, you'll pay twice as much interest. Right? All the numbers will change. If you just want to budget more, good for you. Everything works proportionately. But the factors outside your control. Do you want a 30-year loan or a 15-year loan? If you have kids that will be starting college in about 15 years, you just have some toddlers at your house, maybe you want a loan that pays off right before you have to start paying for your kids going to college. Then that is going to mean you have a smaller house. Not half as small, but smaller, since you're trying to cram the money into less time. What about if your interest rates were cheap? If interest rates gets cheaper, that's great. You get more house. When the interest rates are half, you don't get double the house, but you get a lot more house. And if the interest rates doubled, that doesn't hit you terribly. You don't get half the house, but you get a big reduction. So